Use L'Hopital's rule to find limit when x tends to 1, ln of x squared divided by x minus 1. Despite it's already suggested that you should use L'Hopital's rule, your first step should be to substitute 1 for x and see clearly that you get 0 over 0 or infinity over infinity, so that L'Hopital's rule can be applied. Because in general there may be required some additional transformations to get expression which is 0 over 0 or infinity, or it may be not given at all that you should apply L'Hopital's rule, and when you get 0 over 0 or infinity over infinity, you understand that L'Hopital's rule can be applied. So let's check here, and we can see that when x is 1, we get ln of 1 is 0, divided by 1 minus 1 is 0, so 0 over 0, so L'Hopital's rule can be applied. And it says that such limit is equal to limit, when x tends to 1, derivative of the numerator divided by the derivative of the denominator. So ln of x squared derivative, it's what? We can see that ln is without power, so we apply chain rule according to more complicated argument, and we apply the same rule as for ln of x derivative, and it's 1 over x, but we write this argument instead of x, so it becomes 1 over x squared and argument derivative, which is 2x. And so it's the derivative of the numerator, and divided by the derivative of the denominator, x minus 1 derivative is just 1. And we substitute 1 for x again, and we can see that it's what, just 2 over 1, so it's 2, and it's the required answer. You may simplify, but it's clear here that it's just 2. And if you get 0 over 0 or infinity over infinity, you can apply L'Hopital's rule again, and you may apply this rule absolutely any number of times, but every time you should get 0 over 0 or infinity over infinity, so that L'Hopital's rule can be applied. And notice that if you get limit 0 over some number, it's 0, so limit is 0. Such limit exists. But if you get number divided by 0, it's infinity, and we say that such limit doesn't exist. And if you get 0 over 0 or infinity over infinity, it's called undefined, and it doesn't apply that such limit doesn't exist. It's not clear what value of such limit is, and we apply what? We can simplify such expressions or apply L'Hopital's rule, because it may be like this: x minus 3x squared minus 9, and you can see if you apply 3, it becomes 0 over 0. So in general it may be applied L'Hopital's rule, and it becomes what, 1 over 2x, and it's just 1 over 6. Or you may just simplify it. Now it's this expression is undefined, but you can see that x squared minus 9, it's what? It's just x minus 3, x plus 3, x minus 3 cancels, and you get 1 over x plus 3, and when you substitute 3, you get 1 over 6, so such limit exists and is 1 over 6. Next, limit when x tends to 0, tangent square of x divided by 1 minus cosine. So again, the first step, we just substitute this value for x, and we can see clearly that it's what, 0 over 0, so L'Hopital's rule can be applied directly. And what is tangent square derivative? It's again chain rule, but now function raised to some power, and we apply chain rule according to power, and it says that we apply the same rule as for x squared, and it becomes what, 2 tangent and tangent derivative, which is secant squared of x, and divided by denominator derivative, 1 derivative 0 minus cosine derivative, it's what, just sine of x. And again, substituting 0, we can see that it's what, 0 over 0 again, and we can apply L'Hopital's rule. But also, or every time, we can do some simplifications. And let's try simplify it, because we can see that what tangent is sine over cosine, and sine cancels, and it becomes what, 2 cosine in the denominator, and what is secant squared? It's 1 over cosine squared, and finally it becomes 2 over cosine cubed. And now when we substitute 0, we can see that it's what, 2 over 1, it's just 2. So it's not required to apply L'Hopital's rule again, because we can simplify and we get some value, not 0 over 0 or infinity over infinity. B. Given a reason, state whether the following argument is correct or incorrect. Using L'Hopital's rule, limit x tends to 3, x minus 3 divided by x squared minus 3 is a limit. You can see that it's just applied L'Hopital's rule here. But let's check. When x is 3, it's 0 over not 0, because it's 3 squared, 9 minus 3 is 6. So L'Hopital's rule cannot be applied here, and it's not true. And how to calculate this limit? It's 0, and it's actually 0 divided by number, it's just 0, so limit is 0. So we write the next that it's incorrect, is incorrect, because denominator is not 0 when x is 3. So limit is not 0 over 0, and L'Hopital's rule cannot be applied here. And that's all for this question.